Hello everyone, Roman here from Code Climate. I work on Velocity, an engineering management platform that empowers engineering organizations to achieve excellence across people, process, and code with data-driven insights. I will be a speaker today on how to boost your engineering development process using code cycle time. During this presentation, I will first define what is cycle time and why does it matter. Then how can we break it down into components to match your implementation process and how to go about improving them independently. Then we'll talk about how to introduce metrics into your organization. And lastly, how to set goals using those metrics and laying down some best practices. First, what is code cycle time? It represents the duration between the first commit of the pull request being pushed to your favorite version control system and the deployment of that PR to production. Why does it matter? Think of cycle time as the heartbeat of your engineering organization. It gives you and your team an overall understanding of how quickly fixes or new features can get to your production environment. There is a direct correlation between how quickly your team can push value to production and how dynamic your organization is as a whole. From a business standpoint, the faster the organization can react and innovate, the shorter the time to market. The shorter the time to market, the more markets you can win. From a quality standpoint, being able to push fixes quickly to production increases the overall stability, of course, but also increases the organization's confidence in the process of pushing new features continuously. And for your team, shipping could quickly drive developer satisfaction as engineers value that their work impacts their user base. Some research shows that elite engineering performance is tightly coupled with faster business growth and higher profitability. For any additional information on that, I invite you to check our blog at codeclimate.com/blog. Let's break down cycle time into its four underlying metrics. Here is a simplified activity diagram of a feature development lifecycle from the development to the deployment. The first metric we want to isolate is time to open. It represents the durations between the first commit being pushed and the PR being open once the feature's implementation is complete and that the engineer is working on the PR deems it production ready. The second metrics we want to talk about is time to first review. It represents the time the PR stands waiting for a reviewer to be picked up and how long it will take that reviewer to start its first activity on the pull request. The next one is time to approve, and it represents the time it took to approve the PR and how many cycles did your team go through to get the check of approval. And ultimately, time to deploy, how long does it take for your approved PR to make it to production and get exposed to your end users? But let's dive in and start talking about the first component, time to open. Time to open has the largest impact on the overall cycle time. Focusing on improving time to open first will impact positively the review process and the cycle time holistically. And we do this by pushing small batches, opening PRs quickly, that allow the PR to be picked up quicker, also allow the review to be more in-depth, and allow us to have less risky deployments. How do we go about decreasing the time to open? We want to reduce multitasking to limit the amount of work in progress. Working on too many features in parallel is costly due to context switching, but it might also be a sign that the reviewing is the bottleneck. Try to limit more work in progress in favor of peer reviewing. Then you want to identify and limit rework. Rework is a natural step in software development, but too much of it could be a sign of an upstream process issue. If, for example, you start working on a feature and you identify an edge case that was not covered in a product description, and fixing it will impact the overall behavior of the feature, you have to realign with the product team, and that rework has an impact on the development cycle. Another example is when you start working on a feature and eventually you get stuck and you have to start over. It is cheaper to get stuck and start over on a piece of paper with pen and eraser than starting to write code and have to do it all over again. And track and reduce pull request size. The smaller the pull request, the faster the PR is open and the faster it gets picked up. Which takes me to the next component, the time to first review. Time to first review is a direct reflection of your team's collaboration patterns. Fostering a culture of collaboration and team responsibility over shipping feature has a direct impact on how quickly a peer review will occur. Peer reviewing is a great opportunity for the team to share knowledge and increase the code quality, which in the end will increase the strength of your organization engineering skills. Slow reviews will increase work in progress. As an engineer, once you open a PR and wait for comments, the natural next step is to start working on another feature. If reviews are slow getting picked up, you will have to address feedback on multiple open PRs while you're working on a new feature, and that context switching will impact the quality of your work. And you want to balance fast reviews with the context switching of the reviewers. I was talking about how context switching is expensive for the engineers to build new features, but it's also expensive for the reviewer. As a team, try to find the right balance between a review being picked up fast and factoring the context switching for the reviewer himself. Reduce the time of first review. First, we want to prevent scope creep. Set the target of your PR and try not to deviate from it. It is easy to add an extra line of code for the overall well-being of the code base, but the reviewer needs to understand the context of the PR, its goals, and any additional scope will raise questions and cause confusion in terms of increasing the PR size. Build a culture that prioritizes reviews. Pushing code through the pipeline is more important than running new one. I am a New Yorker, and to me it's the same as you let people out of the train before you go in. Foster a collaborative culture where reviewing each other's code is more important than running your own. For example, you could prioritize reviewing in the morning, address your comments on your PRs in the afternoon, and when those two things are done, then you write new code. And balance review involvement. Code reviewing is a collaboration. Make sure to spread the load amongst your team members. The next component I want to talk about is time to approve. Align the desired outcomes of your code review. In your description, align the reviewer with the goal of the review. Setting the context will increase the quality of the review itself. Are you writing a new feature? Are you refactoring code? Or do you want more parallels when you're writing? Make sure to balance speed and thoroughness. The goal here is not to skim through the whole PR and click approve, but how as a team can you provide the highest quality review in the shortest amount of time? So how do we get by reducing time to approve? First, we want to increase the review coverage. Review coverage is the ratio between the number of lines of the PR versus the number of commented lines. And we want to increase the review influence. And the review influence is the ratio of commented line with the number of response or the number of action taken from a comment. Looking at those two metrics in tandem gives you a good understanding of your existing reviewing process. Increasing those two metrics boosts the overall quality of one review cycle. The most important point is to reduce the number of review cycles your team will have to go through to get your PR approved. The lag between each review cycle is what impacts the most time to approve. Increasing one code review cycle quality should lead to an ideal case of 2 review cycles per PR. The last component, time to deploy, is the final barrier between customers and value. Also think of how you can communicate internally and externally about new features making into production. It's the critical indicator of your continuous delivery practice as an organization. Think of what is blocking your team's work from reaching your users. And there are 3 main types of issues we can talk about: technical, behavioral, and process. Let's talk about the behavioral impediments. What starts from a good intention of not breaking anything can lead the organization being shy of deploying. Therefore, increasing the time to deploy, and as bigger deploys become, then riskier uh, a bug that makes it to production, the fix will follow the same process to make it to production, which snowballs into more hesitation to then deploy to production. Pushing continuously small features is less risky. Pushing fixes quickly will drive a more blameless culture and help your team focus on getting the fix out of the door. Creating space to make mistakes favors creativity and allows your engineers to take some risks by using new patterns, new tools, etc. In terms of technical impediments, we want to make sure that your CI tool is fast and reliable. Make sure that your flaky test and your test coverage is adequate. But also use other tools like adapting feature flags. Feature flags allow your product team to control the rollout of a feature and measure its impact. It allows your organization to iteratively make the product better and give confidence to your product team to continuously release bit by bit. Continuously improve production monitoring. Be proactive about fixing the environment. There is nothing better than fixing a bug before it was caught by a customer. This is the overall view of the cycle time, its four components, and all the variables that influence them. To summarize, to shorten your cycle time, push small PRs, create a culture of collaboration and a review-first approach. Increase the quality of your reviews, and if you deploy continuously, you will increase the confidence of the organization in the deployment process. How do you get by introducing metrics in your organization? As an engineering leader, you want to align your team on why you want to bring metrics to your organization and what problems do you want to solve with it. Do you want to leverage metrics to improve velocity? Do you want to leverage metrics to reduce incidents? Do you want to increase code quality in production, etc.? Address your engineer's problems first. Engineering being the foundation of your organization, fixing your engineer's problem first will have a positive ripple effect across the organization. And make sure to make your team part of the goal setting effort. Share the plan and celebrate all the small wins. How do you set cycle time goals? Set your objective as an SLO. For example, the goal is to get 90% of a pull requests to have a cycle time under 3 days. Review weekly or monthly and focus on the change over time, not the starting point, and celebrate every small wins. How do you use data to drive your performance? First, make sure to supplement metrics with qualitative data. Make sure to gather non-numerical data about your process and your team when interpreting metrics. Interpret metrics with the appropriate context. What's going on in your organizations impact the overall productivity. Bring the context to the table to help you understand fluctuations better. And review multiple KPIs together for a balanced view. Group sets of metrics together to have a better overall understanding of what is going on and often reset your expectation and your goals. Thank you very much for listening. If you're interested in these ideas, come out and get a copy of our free book, The Engineering Leader's Guide to Cycle Time, written by our CEO, Brian Helmkamp, at the link on your screen. And come check out how Velocity can help you and your team with insight metrics at codeclimate.com.